Okay, so we started out by saying if you want to reflect over the x-axis, you take the point x comma y and you map it to x comma negative y. So we're going to do this for all 3 points on this triangle right here, this triangle TRY. So what we're going to do is we're going to write down the pre-image, which is the original point, okay? So let me get this in here for you guys. So the pre-image, we need the coordinates of the points. So the point T is 1 left and 2 up. So that is at -1, comma 2. And then the point R, that is at 3 right and 4 up. So that's the point 3, comma 4. And then the point Y, that is at the point 2 right, 2 up. So that's 2, comma 2. Now they want me to show the work like in this middle column right here. I think for this, I don't think we're going to need to do that. So what I'm going to tell you is then the image, what we're going to do again is we're going to leave the x the same and just take the negative of the y value. And then we're going to replot this thing. So when we get the image, instead of being point T, it's going to be called point T prime. And then we're going to leave the x the same, and we're going to take the negative of the y value. And then R prime, we're going to leave the x the same and take the negative of the y value. And then Y prime, we're going to leave the x the same and take the negative of the y value. And then we're going to plot these 3 points, and we should get an image of this thing that is a reflection over the x-axis. So let's plot those points. So T is at 1 left, 2 down. That would be T prime. And then R is at 3 right, 4 down. So that should be R prime. So the prime ones are the image, okay, after the transformation. And a reflection is really like a flip, okay? We're going to flip this thing over the x-axis. And then Y prime, that's at 2 right, 2 down. So that's Y prime. And then we're going to redraw this thing, so it looks like, maybe I'll get a little bolder. So it looks like this. Okay? So you can see that, hopefully you can see that I just flipped that thing over the x-axis. Now the next one is a reflection in the y-axis. So a reflection in the y-axis, if I wrote that down like I did last time, that would kind of look like the point x comma y. That is going to map to, well, you take the negative of the x and you leave the y value the same. And that's going to flip the figure over the y-axis. All right, so let's do it again. So get this chart where you guys can see it. Okay, so again, T is the same point it was before. It's 1 left, 2 up. So that's 1 left and 2 up. R is again 3 right, 4 up. And Y is again at 2, comma 2. Okay, and then we're going to leave the y value alone, and we're just going to take the negative of the x. So T prime, we are going to take the negative of the x and leave the y alone. And then R prime, we're going to take the negative of the x and leave the y alone. And then Y prime, we're going to take the negative of the x and leave the y alone. And then we just got to plot these 3 points. So T prime is at 1 right, 2 up. So that's T prime. And then R prime is at 3 left, 4 up. So that is R prime. And then Y prime is 2 left, 2 up. That's Y prime. So hopefully you can see that what happens is when you reflect across the y-axis, you take the point R and it comes straight across the y-axis. All right, and it makes a 90-degree with that, those two, I don't know what you want to call them, those two segments make 90 degrees with the y-axis. And then this distance right here is the same as this distance right here. So that's what you're doing. There you go. So let's plot this thing then. So we have T prime, R prime, and Y prime. So let's connect the dots. So that's your reflection over the y-axis. All right, let's keep going. Now, again, we're kind of in a weird order, especially when I couldn't get my iPad to function properly here. So we're going to start talking about some dilations right away here, because this is actually page 8 now that's appearing right here. But I don't think that's going to be a problem. I can explain it to you guys as we go. So what you've got is, in example 2, they give us 3 points, and they want us to plot those very quickly. So let me do that. So the 3 points we have are A is at -2, 0, which is right here. Actually, maybe I can zoom in a little bit on this. Okay, so A is at -2, 0, that's right here, 2 left. B is at 2 right, 4 up. And C is at 4 right, 4 down. So that's A, B, C. Can you guys hear our cat? Our cat is outside my basement window meowing right now. So we're going to draw this thing. Okay, so there you have the original triangle ABC. And then we want to do a dilation centered at the origin. And so a dilation, what we do, we can see the scale factor of the dilation right here is 1/2. So all we got to do is multiply each of the coordinates by 1/2. And that's going to give us a new triangle that's an image that's half as large as the original one. So really, we're just going to multiply all the coordinates by 1/2. All right. So I got to write down all these coordinates. So point A, that was at -2, 0. Point B was at 2, 4. Point C was at 4, -4. And then the dilation, again, means I'm just going to multiply all the coordinates by 1/2. So, for example, for like the bottom point here, you're going to take, for point C, you're going to take 1/2 times 4, and then 1/2 times -4. Like that. Actually, let me move this down here so you can see. So 1/2 times 4, comma, 1/2 times -4. Okay? That's all you got to do. So multiplying by 1/2 is the same thing as dividing by 2. So you're just going to divide all these coordinates by 2, the x coordinates and the y coordinates. So that means our image then our image is going to be, let's see, what do we got? So we got to divide every coordinate by 2. So A prime, that's going to be at -1, 0. B prime, that's going to be at 1, 2. And C prime, That's going to be at 2, negative 2. All right, so now we're just going to plot those and we'll be done. So A prime is at negative 1, 0. That's 1 left. B prime is at 1 right, 2 up. And C prime is at 2 right, 2 down. And so here's your image. The blue one is the image. So that is half the size of the original one. Now what you would see is if you drew a line from the center of the dilation, which is at 0, 0, can you see if I draw a line out from 0, 0 that these are going to be on the same line when I go through the vertices of the triangle? And then what you would see is if this distance is, how do I do this in a color where you guys can see? This distance in red from, let's go a different color. Let's go with this. This distance in red right here, the distance from the center 0, 0 to the point B, if you look at that distance, then the distance from 0, 0 to point B prime is going to be half of that. Let me take all that out of there for you guys. Okay, so let me label these points real quick. So again, this was B prime, this one was A prime, and this one is C prime. All right, so that's how you do a dilation. I don't know if I'm going to go through all of example 3, but maybe I'll do one of the points just so you guys can see it. Same idea on this dilation, except now the scale factor of negative 1/2. Well, if we do a scale factor of negative 1/2, we're just going to multiply all the coordinates by negative 1/2. So for example, if we do, I don't know, which one should we do here? If we do the point G, that point is at negative 2, 4. Well, then the dilation of that by negative 1/2, a scale factor of negative 1/2 centered at 0, 0, you're just going to do negative 2 times negative 1/2, and then 4 times negative 1/2. So basically, multiplying by negative 1/2 is the same thing as dividing by negative 2. So if you want the image, then G prime here, take negative 2 divided by negative 2, you're going to get positive 1. Take 4 divided by negative 2, you're going to get negative 2. And I'm not going to graph this one and do all 3 points. And this is what your homework is like on Delta Math today. All you're going to do on Delta Math today is you're going to transform 1 point. You're not even going to do 3 points and do a triangle. You're just going to do one of the vertices, that's all. So let's move on to see if I can get this iPad to work and sync up, and we'll try to do another page here. So let's try to see if I can get a page to turn here. I just turned the page on my iPad again, but it did not turn here for some reason. I'm looking at the point. Oh, this is crazy. Let's see if I wait a second, if there's just a delay. Well, let's see if I can get another page to match up. All right, we can try it. I'm on the right page with this one, so let's try this one. So this one's on translations, which is a slide, okay? So when you slide it, you can't turn it, you can't flip it, and you can't, you know, make it larger or smaller. You know, when you did the dilation, you were actually making similar figures that were the same shape but different sizes. When you do the translations or the rotations or the reflections, you're going to get a figure that's congruent to the original one. In this case, the translation, you cannot turn it, so you can't rotate it. You can't flip it, so you can't reflect it. Okay? So all you're going to do is slide it. So let's try one of these. Let's try, I guess we'll just try example 3. I think we can do the whole thing in one. No, that's a rotation, so we can't do that one yet. All right, so we'll do example 1. So if you look at example 1, again, this is just going to be a slide. So the rule for the transformation is right here. All right. So it says you're going to add 12 to the x coordinate and you're going to subtract 5 to the, from the y coordinate. Now in your book, how they write that is they actually write that as, they'll either write it like this, or sometimes they use a vector notation. And in their vector notation, what they do is they write it like this. They make this weird bracket like this, and they'd say positive 12, negative 5. Well, all that means then is that they're going to go right 12, actually, they're going to go right 12 units, and then they're going to go down 5. Okay, so the same thing, it means the same thing that we have written right here. Okay, so if we write these points down real quick, so we've got point A, so point A is at negative 1, 8. That's the pre-image. Point B is at 2, 12. Point C is at 5, 8. And point D is at negative 1, negative 2. Okay, so the slide, we're just going to take that quadrilateral. It would have 4 corners. And we're just going to slide it 12 to the right and 5 down. Well, that means all we got to do, like for example on, I don't know, point A here. All we got to do is take the x coordinate plus 12. And then the y coordinate minus 5. Okay, that's what goes in. Well, I guess I could have fit it right here. Negative 1 plus 12, 8 minus 5. All right, so then that would give us a image point, A prime. So A prime is going to be at negative 1 plus 12, that's 11. And 8 minus 5 is 3. And then we're just going to do the same thing for the other 3 points. So then B prime, we're going to add 12 to the x. That gives us 14. And then we're going to subtract 5 from the y. That gives us 7. And then for C prime, we're going to add 12 to the x. So that's going to give us 17. And we're going to subtract 5 from the y value. That'll give us 3. 8 minus 5 is 3. And then D prime, we're going to add 12 to the x, so that's going to give us 11. And then we're going to subtract 5 from the y, that's going to give us negative 7. Now, we don't have to plot this one, and it wouldn't fit on that grid over there anyway. So that's how a translation works. So you just moved it to the right. You took that whole figure or point. You take each corner one at a time, and you move each one 12 to the right and then 5 down. All right, let me see if I can get any of these other pages to sync up on this thing. So let's see what else I can do. Yeah, this is really bizarre that I can't get these last 2 pages to sync. Like right now, you guys are on reflections. You're on page 3 and 8, and I'm on page 7 and 4 on my iPad, so I cannot get this thing to match up. So somehow something's messed up. I just can't figure out what. I'm going to try to resync this thing again one more time. All right. So 192.168. So again, I have the first page matching up okay. Yeah, so look at that. That's the part that I wrote on for, yeah, this is, I don't know, this is not working at all. All right, that part matches up now. Sorry for the delay again. All right, I think I got this page matching up now. Yeah, I think I do. So let's try a couple of these then. So the dilation part in example 1, I've already explained that. So all you'd have to do on that one is the dilation is with a scale factor of 3. So again, you're going to get similar figures. You can see that in this little smiley face picture here. So you get an image and a pre-image. So this would be your pre-image. And this could be your image. And again, all it does is it's just an enlargement or a reduction. So those are similar figures. They have the same shape. They're just different sizes. So when you look at example 1 here, the scale factor here is k equals 3. So all you got to do is multiply all the coordinates by 3. All right, so I'm not going to do the whole thing. But for example, if you did point B is at the point -5, 10. So the dilation, again, if the scale factor is 3, the k equals 3, and it's centered at the origin, then all you do is you do 3 times -5, 3 times 10. So you just triple all the coordinates. So in this case, you would get -15, 30. So hopefully that's pretty clear. So then let's try these other 2 reflections since this stuff is all mixed up here. So let's try this up on the upper right here. Let's try a reflection over the line y equals x. So this one right here. Okay, so the rule for this one, if you, again, you're going to take a test on this, but you're going to have this packet and you're going to have all these rules. So the rule you're looking for on this one for this reflection in the line y equals x, first of all, the line y equals x, that is the line, that's the line y equals 1 over 1x plus 0. So that's the line we're reflecting over. So that line would actually be this line right here. So it's that diagonal red line right there. Well, then the rule is not too bad. So if you look at the rule, it just says take the point xy and you just flip the coordinates. You make the y value the x value and you make the x value the y value. So you just reverse the coordinates. So if we write these coordinates down again, the coordinates for point T, that's 1 left, 2 up. For point R, that is 3 right, 4 up. And for the point Y, that would be 2 right, 2 up. All right. Well, then all you got to do, again, is just flip the coordinates to get the reflection over the line y equals x. So that means you're going to flip them. So T prime is going to be at 2 comma negative 1. R prime, that's going to be at 4 comma 3. And Y prime, that's going to be at 2 comma 2. So all I did was reverse the coordinates. So let's plot that one. So T prime would be at 2 comma negative 1. So that's 2 right, 1 down. R prime would be 4 right, 3 up. So 4 right, 3 up. And Y prime would be at 2 comma 2. All right, so now if I graph that, or if I connect those dots for you guys, it should look like this. So that's a reflection. That's flipped over the line y equals x. And again, this would be T prime down here, and this would be R prime. So what you should see is you should see that T is reflected right across this line, y equals x. And it goes to T prime there. This would be 90 degrees right here. And then this distance right here would be the same as this distance right here. Okay, so now the next one at the bottom here, this is a reflection over the line y equals negative x. Well, I'm not going to do the whole thing. But the line y equals negative x, that is the line, this thing is y equals negative 1 over 1x plus 0. And the plus 0 got cut off on you guys there. Let me fix it for you guys. So this thing again, this is y equals negative 1 over 1x plus 0. Like that. Well, that line would be right here. That would be a diagonal line going this way. Like that. So we're not going to do all of these points, but you can see the rule right here. And you're going to have your notes to do this. So if you have the point xy and you want to reflect it over the line y equals negative x, then it goes to negative y, negative x. So I'll write that rule right here. So xy would map to negative y, negative x. So you're just going to flip the coordinates again. X is going to become Y and Y is going to become X, but then you take the negative of each of them. So if we just did one of these points, we're not going to do all of them. So if we did the point, I don't know, what should we do? Let's do the first one. So T was at 1 left, 2 up. Well, then we've got to flip them and take the negative of each of them. So that means that T prime then is going to be at -2, +1. Okay, so we reversed or switched the X and the Y, and we took the negative of each of them. And so then if I put the point T prime on there, that'd be 2 left, 1 up, which would be right here. So that's T prime. That's reflected over the line Y equals -X. Now let me see if I can get any more of this in today, if I can get my iPad to work. So let's see. So that's not matching up. I want to do something with a rotation with you guys because you haven't seen how to rotate. But for some reason, I can't get my iPad to sync that page. Let's see if I can get rotations up here. Because if I get you to the rotations, I think it'll be okay. Let's see if there's just a delay. Yeah, no matter what I do, I can't get that rotations page to come up. It's on my iPad, but it won't show. I think the rest of it's working now. Yep, so we did some translations. We didn't do that. We'll save that for in class. We did some reflections. We did some dilations. I just can't get on the rotations page. And we're going to run out of time too. I don't know, I might try, I'm on my Wi-Fi at home. I might try plugging into the Ethernet and see if that'll help. I don't know if it will or not. At least if I can point out what you're supposed to do before you go. So I'm going to try that really quick. I don't think it's going to make a difference. I just don't know why this thing's not working. All right, let me see if anything happens. Okay, so there's the first page. There's the translations. We're not doing that one. There's the reflections, dilations. It will not show me the rotations page. All right, let me see if I can write a couple notes here just to send you guys on your way then. And then I'll let you go. I'm just going to write this stuff down. I'll have to go over it in class with you guys next week because I can't figure out what my iPad's doing. Yeah, it's so weird. It goes to that blank page, but it will not go to the rotations page no matter what I do. So I'm zooming on the rotations page, and it's doing nothing on your screen. Well, it's zooming, but it's not on the right page. Super frustrated. Let's see. Okay, so I'm going to go to a blank page. I'm going to write a couple rules for you guys so I can get you guys out of here. All right, if you want to rotate, if you want to go 90 degrees 90 degrees clockwise or 270 degrees counterclockwise. So how I'm going to abbreviate this for you guys is I'm just going to say that's 90 degrees clockwise or 270 degrees counterclockwise. I'm going to abbreviate it like that. So what you do is you take the point XY and you map it to the point Y comma negative X. Okay? So and again, if you guys printed this thing out, you should see it it's on page 5 and page 6, it looks like. That's the rule for rotating 90 degrees clockwise or 270 degrees counterclockwise. And I'll have to show you in class why that's true. So you switch the coordinates and you take the negative of the X value. Then the next one is if you want to go 180 degrees. So if you want to go 180 degrees clockwise or 180 degrees counterclockwise, that one, the point XY gets mapped to the point negative X, negative Y. So you just take the negative of each coordinate. And then the last one you'll need, and you probably need these for the delta math, and you can look them up in the transformation book if you printed it at home, or you can look at it online on Schoology. The last one is if you want to go 270 degrees clockwise, which would be the same as 90 degrees counterclockwise. That one, the point X comma Y gets mapped to negative Y comma X. So you switch the X and the Y, you take the negative of the Y value. And that's the best I can do for you today. Sorry about the technical difficulties. I don't know what's going on, why this thing wasn't working. Your assignment, again, is you're just going to move 1 point. So if they ask you to do a 270 degrees clockwise rotation, you are just going to take whatever point they give you guys, and you're going to switch the X and the Y and take the negative of the Y. So hopefully that makes sense. That's what you have to do on your Delta Math assignment. You have 10 problems on Delta Math. That'll be for 10 points. There is no assignment out of the book. I will see you guys in class next week, okay? In person. Have a good weekend.
Bye, have a good weekend.
Yeah, sorry about that today, guys. Have a good weekend, guys. Anthony, you still out there?